All right, let's dive into one of the most fundamental systems on our planet. It's a system so massive it actually shapes our climate, yet it's so personal it's right there in the glass of water you might be holding. This is the story of Earth's endless water cycle.
But first, let's start with a number that might just shock you. 3%. That's it. We all know we live on a blue planet covered in water, right? Well, only 3% of all that water is fresh water. The rest is salt water. And that tiny little slice is what all life on land, including you and me, depends on.
And here's the thought to really wrap your head around. The water we have on Earth is ancient. It's the same water that's been here for, well, basically forever, just constantly moving and changing form. The water cycle isn't making new water. It's just the ultimate recycling program.
So here's our roadmap for this explainer. We're going to cover water's epic journey, starting with the 4 main stages you probably remember from school. Then we'll look at where water is actually stored. From there, we'll dive into how we humans are changing the game, what a warming world means for all this, and finally, what our water future might look like.
Okay, let's kick things off with a quick refresher. The engine of this whole system, this simple circular journey that water takes, can be broken down into 4 main stages.
And here they are, the 4 stars of the show. You've got evaporation, where water turns into a gas, then condensation, when that gas forms clouds. Next is precipitation, when water falls back to Earth. And it all ends with collection, where it gathers up to start the journey all over again.
It all really starts with the sun. Its energy beats down on oceans, lakes, and rivers, and that heat causes water to evaporate and rise up as vapor. As that vapor gets higher, it cools down and condenses into tiny droplets, which clump together to form clouds. And when those droplets get heavy enough, they fall as precipitation, rain, snow, hail, and collect back on the ground, ready for the cycle to begin again.
But evaporation isn't working alone. There's another huge player called transpiration. Think of it as plants breathing. They suck water up through their roots and then release water vapor from their leaves, and it's a massive contributor of moisture to the atmosphere, a really vital piece of the puzzle that's easy to forget.
Now that simple 4-step loop is a great model, but, you guessed it, the reality is a little more messier. Water doesn't just move around constantly. It actually spends a whole lot of time just hanging out in storage.
So to really get it, scientists talk about pools and fluxes. A pool is just what it sounds like, a place where water is stored. That could be an ocean, a glacier, or even the atmosphere itself. A flux is simply the movement of water between those pools, like when evaporation moves water from the ocean pool to the atmosphere pool. And the biggest pool, by a long shot, is the ocean. This chart really puts it into perspective. Over 97% of all water on Earth is saltwater, which again leaves that tiny, precious 2.5% of fresh water for all of us on land.
But let's zoom in on just that little slice of fresh water. Where is it? Well, here's another surprise. Almost 70% of it is frozen solid in glaciers and ice sheets. Another 30% is hidden way underground as groundwater. So the easily accessible stuff in lakes and rivers, that's just a tiny, tiny fraction of an already small amount.
And how long a water molecule stays in these pools? Well, it varies wildly. This is what's called residence time. A molecule might only hang out in the atmosphere for about 9 days, but if it makes it into the ocean, it could be there for over 3,000 years. And in deep groundwater, we're talking 10,000 years before it might see the light of day again.
For thousands and thousands of years, this cycle just did its thing. But that's not the story anymore. We have officially entered an age where human activity is fundamentally changing how water moves across the planet. And that's the crucial point here. We are no longer just passive observers of the water cycle. We are active drivers. Our cities, our farms, our dams, we've become a major force, rerouting the plumbing of the entire planet. You can see the difference pretty clearly. In a natural landscape, rain soaks into the ground. But when we build a city, we cover everything in concrete, so the water has nowhere to go but to run off, often causing floods. We build massive dams that totally change a river's flow, and we're pumping water out of underground aquifers way faster than nature can ever hope to refill them.
So why does all this meddling matter? Because we depend on this cycle to work predictably for, well, absolutely everything. The water in your tap, the food on your plate, the electricity powering your screen right now, the industries that build our world, it's all tied to water. So, on top of all our direct disruptions, we're adding another huge layer of stress, a warming climate. And it's basically putting the entire water cycle on steroids.
The basic physics here is actually pretty simple. When the atmosphere gets warmer, it can hold more moisture. Think of it like a bigger sponge in the sky. For every 1 degree Celsius of warming, the air can hold about 7% more water vapor. And what that leads to is something scientists call an intensification of the water cycle. It's like someone turned the volume knob on the whole system way up. There's more energy, more moisture in the air, which means when it rains, it can rain harder, and when it's dry, it can get a lot drier.
This whole intensification thing creates a wild paradox. It means we get more extreme concentrated downpours that lead to devastating floods. But at the same time, the dry periods between those rain events get longer and hotter, which leads to more severe droughts. We end up with both extremes, too much water and not enough.
And this is where it gets really concerning, because it creates a dangerous positive feedback loop. See, water vapor itself is a potent greenhouse gas, so a warmer atmosphere makes more water evaporate. That extra water vapor in the air traps more heat, which, you guessed it, warms the atmosphere even more, causing even more evaporation. This cycle starts to feed on itself.
So, where does this leave us? Well, really understanding how this cycle is changing is the critical first step toward figuring out how we're going to navigate the future.
Let's just quickly recap the big takeaways here. First, the fresh water that keeps us alive is incredibly rare. Second, the cycle that delivers that water is becoming more volatile, more extreme. And third, our future, our health, our security, our economy, it all hinges on us understanding and protecting this vital planetary system.
The planet's ancient life-giving rhythm is being thrown off. The water cycle is changing in some really fundamental ways, and those changes are picking up speed. So the only real question left is, are we ready to change with it? Thanks for joining me for this explainer.